Thank you very much, Daniel. And yeah, first of all, I mean, it is an important date for Kamailio itself, with an important anniversary, but it is also a very important anniversary for me as well, because I mean, this marks my 10th year here at Kamailio World, so thanks for welcoming me here for so long, so that I could pester you all about WebRTC and Janus for so long. Even though it makes me a little bit sad, because look how young and fresh I looked back then, so not that young anymore. Now I'm an old monkey, an old guy over there, but still interested in the same things, so I still work a lot on Janus. I've been playing a bit with Quick as well. Some of you may remember from last year I talked a bit about that. And I'm one of the co-founders of a small company based in the south of Italy called Meetecho, and as everybody here, we love standard protocols, we love open source, and basically everything that we do revolves around that. And we do a lot of consulting services, commercial support around a couple of projects, one of them being Janus, even though today I'll be talking a bit more about another project that we started recently that is called Juturna. And I have to say in advance that this is not a project that I worked on myself. This is really Antonio Bevilacqua's and Paolo Saviano's baby, so they are two colleagues of mine. So I hope I won't mess up anything, otherwise I'm getting a very angry call later on, but hopefully I'll do their work justice. And just to give you basically a bit of a better understanding of how we came up with this project, basically it all started with, basically as most of you did, we needed some form of live transcriptions for our own services. In our case, it was for IETF meetings. And initially, as many did, we started experimenting with existing services like DeepGram and stuff like this. So basically getting RTP out of Janus and make it available to services like DeepGram for the purpose. But we really wanted something that we could have more control on, something that we could deploy on premise and do more things with, which is where Antonio came in. Basically, he is a machine learning expert, and he started working basically on a solution to use Whisper around that instead, which he talked about at JanusCon a couple of years ago, a solution that he created called Wispy. At the same time, a few years before, Paolo had come up with basically an idea for a more general purpose architecture to play with AI and machine learning and stuff like that. And that was before this was all the rage like today. So we wanted to play a bit with real-time media and, for instance, sentiment analysis and a few other things that were available, which he had talked about at the previous edition of JanusCon. And so, long story short, the idea came out to try and merge the two efforts. So basically to try to take that vertical solution, that transcription service that we had done, and basically generalize it very much into a much more general purpose architecture, which we could use to do much more than just that. Which basically in a nutshell is Juturna, and I'll talk about it in a minute. And if you're curious about where the name comes from, it basically comes from Roman mythology, because I am very passionate about that. So, for instance, Janus comes from that because it is the gods of transitions, and at the time it made the perfect sense for a component that was translating between the legacy word in quotes and WebRTC, which was the future. And in Roman mythology, Juturna is the wife of Janus, so it made perfect sense to have the two projects have some sort of a synergy between the two. And most importantly, Juturna was also the goddess of fountains, wells, and springs, which, sorry, can you still hear me?
Yeah, you lost it.
Oh, sorry about that. Okay, let's see if this is better now. Yeah, so Juturna was also the goddess of fountains, wells, and springs, which made a lot of sense because basically, as we'll see, Juturna is a pipeline-based component, and so that clicked. And so in a nutshell, basically, Juturna is just to quote the project website, it's basically a plugin-oriented streaming data pipeline engine written in Python. And what this means basically is that we try to make it as easy as possible to take data from live sources like RTP streams or something like that and put that data through arbitrary transformations with using nodes that anybody could bring to the table, basically. Which means a strong focus on real-time data, because that's what we work with, multimedia, because we want audio, video, but not only that in principle, and most importantly, something that could be as generic and extensible as possible. And we really focused on the modular nature of the framework. And we really, when the choice of Python was not done by chance, because we really wanted something that was as close as possible to, let's say, the language of machine learning in general. So a lot of models and projects use Python as the core language for that, which means that it should be as easy as possible and as transparent as possible to, let's say, import that functionality into custom nodes that you can add to Juturna to add more functionality, which is why we invested a lot of effort also on making it a very good component for fast prototyping. So anytime we have a generic idea for something new that we want to do with this, it should be as easy as possible to come up with a new node that we can add to a pipeline and do something with that in principle. And this is, of course, completely open source. There are a couple of links there to the repository, to the package that you can find to get it on PyPy, and also to the documentation. Antonio and Paolo did an excellent job documenting everything also when you want to get started and stuff like that. And from a graphical perspective, I mean, it's, if you will, nothing groundbreaking in the sense that it is a traditional pipeline framework, if you want. So you typically have data coming in different forms, and so you have some source nodes that can basically make that data available for processing internally. And then you have different nodes that could be put in sequence, in parallel, or whatever, to transform that data in different ways until you get up to some nodes that can make those results available to the outside world for whatever you need to do with it, basically. And basically, for instance, you could do something, and this is a slide taken from the documentation. For instance, you could have a pipeline where you have audio and video in, you process them both in parallel at the same time, but then the output of audio influences the video, so that, for instance, you have a live transcription of the audio that you relay somewhere, but you also use the live transcription as a subtitle overlay on top of video. Again, a very basic example, but it gives you an idea of the things that you could do with this sort of components. And when it comes to the nodes, let's say, again, it is something that is true for most pipeline sort of projects, but in general, we categorize them in 3 macro categories, if you will, even though in practice, this distinction doesn't really exist because all nodes can actually be all of that at the same time. But in principle, we have source nodes, which are basically nodes that take media from the outside and make it available to other nodes for further processing. And this could be, for instance, a node that can receive RTP traffic and decode it so that other nodes can work with the media. Then you have processor nodes, which is where the actual heavy lifting comes in. And you could have different nodes taking care of different stuff. You could have a node doing voice activity detection, another that transcribes, another that does just video detection, another node that does manipulation of bit streams for whatever reason. Again, this could be whatever you need to do, and whatever you need to add to a pipeline. And eventually you end up with, if you need to make these results available to the outside world in whatever format, you typically have sync nodes where you could have, for instance, very simply an HTTP node that shoots JSON out to somewhere, or maybe another RTP node that basically re-encodes whatever the result is into, for instance, an audio or video stream so that you can send it to another component to do something else. And something that we've been working on more recently, and this is more work in progress, but it's already showing promising results, is some sort of we call it a warp node, because basically all of the nodes that I described so far basically start from the assumption that these nodes have some sort of a local access to the resources that they need to work with. So for instance, you have a machine learning model of some sort that is co-located with the process, and you are talking to the process directly somehow to do things, which may not be always the case, because maybe you want a node that interacts with a service that is somewhere over the cloud or whatever. Or maybe you want to remotize some functionality of Juturna so that maybe different pipelines need to communicate with each other. Whatever the use case, it's useful to have a node that simply acts as an avatar for remote functionality but sits locally in the pipeline itself, which means that it gets payload data from a local node. It remotizes the processing so that it sends these results somewhere else using protobuf, and then gets results back. And then whatever it gets back is what is passed along to the next node in the pipeline, basically. So again, in principle, a very simple thing, but it opens the door to a lot of interesting functionality that could be done. And out of the box, when you download the project from the repo, you get a lot of nodes, basically of the different kinds, a lot of different source nodes, a few processor nodes. You'll see, for instance, a few different alternatives for transcriptions, some plugins to manipulate both audio, video, and so on and so forth, different ways to produce results, and so on. But by no means this should be considered, let's say, a final point. This is really just what we came out with for our own needs or from our own experiments, our own research, and so on. The idea is really that if you download Juturna, really the main purpose is for you to most often write your own nodes out of models that you control or that you created or that make most sense for you for your own use cases, basically. So it's supposed to be as easy as possible to write new nodes in order to enrich the available functionality there. And it's not even nodes that you need to make available. I mean, it's also nodes that you can keep to yourself if you want. And just to give you a practical example of how it works, so basically how we use it ourselves, I mentioned how it all started from transcriptions for us, which is also the most obvious use case for this, if you think about it, because it is a simple pipeline, a simple sequence of steps that you want to do with an audio stream. And we use it in production with Juturna at IETF meetings specifically. And basically, of course, we spent a lot of time trying to make it work as best as possible, and I think we did a good job in order to minimize, for instance, where there were rate hallucinations and stuff like that. And coming to the different nodes, it may be easier to have a look at it from a visual perspective, because basically it is really a quite simple pipeline that is just a sequence of different nodes. So it all starts from an RTP node that takes media coming in from the outside. In our case, it is media coming from a Janus server that using the Audio Bridge plugin, because at IETF meetings, we use the Audio Bridge plugin as an audio conference server that mixes all contributions, both local and remote, which means that the Juturna receives a mixed stream with all the contributions of different people talking in. And this is an RTP audio stream that gets to that audio RTP node over there. That audio RTP node knows the codec it's working with. It can decode it and can make raw frames available in whatever format to the following nodes. In this case, the first node that we encounter is a Silero node that implements voice activity detection just to check whether or not we're dealing with silence or not. Next step is the transcriber node itself that implemented on top of Whisper, Fast Whisper specifically. Then the results of that is passed to a further node that we call an aggregator node that's mostly there to clean up the results a little bit, like get rid of hallucinations and stuff like that. And eventually we notify the results. So eventually we end up with a JSON object that has the latest transcription data, and we can shoot it out via HTTP so that it can be displayed somewhere or presented. And all of this has embedded telemetry as well. So we can basically collect telemetry information for further diagnostics later on in order to debug the pipeline, in order to figure out if there are any optimizations that we can do, whether we need to do stuff or something like that. And basically, the end result is something like this, where you have, for instance, the local venue as a second screen, which also shows the live transcriptions of whatever is happening in the room right now. And remote participants have a tab as well where they can see the live transcription of the session in real time, basically. That's what we use it for over there. And this is, of course, a starting point again for us, because that's where we started, but we wanted to be able to do much more, which is why we came up with that modular architecture in the first place. Because, for instance, yeah, transcriptions are cool, but they can be the first stop towards doing more things. We could do translation, summarization, anonymization are just a couple of scenarios that come to mind. And the ability of, let's say, feeding multiple nodes at the same time, processing the streams in parallel rather than just in sequence and so on, opens the door to a lot of cool things that we can do there. And again, just to show this from a visual perspective, if this is our starting point, where we have a simple pipeline where we go from audio stream to transcribe the stream, we may want to reorganize it a bit, for instance, to again, from the same results, so from that transcribed stream, we can notify it to the same backend as before, but at the same time, those results could be passed to a translator, to a summarizer, and those are processed in parallel so that we end up with more results processed in different ways, all from that same media stream over there. And this is something that we've been working on with a customer of ours specifically. And of course, audio is just the first example, but video makes a lot of sense as well, because there are a lot of scenarios where video does make sense. And in principle, the approach we followed is pretty much the same. So the modular nature of the component is the same, it's just the nature of the media that changes, because of course we all know that audio streams and video streams are not really formatted the same way, where audio is more like a continued stream of samples. With video, you have timestamped images more than that. But in principle, the processing works pretty much the same way. And for instance, in our case, we initially started playing typically with YOLO-based models for the purpose. And for instance, a use case that we used it for was for a European project that we participated in called Io Ti Vedo, where typically the scenario was quite simple. We had, again, Janus feeding live video to Juturna, so it was still hitting an RTP node, but in this case, an RTP node that was more aware of video rather than audio. The raw frame decoded by the RTP node would be passed to a YOLO detector node, and then this YOLO detector would split the results into different ways. On one end, it would basically pass the raw metadata to a UDP notifier, and I'll explain why we use a UDP notifier in a second. And then it would also pass the, let's say, processed image, where, for instance, the results of the detection, like boxes and so on, would generate a new image out of the original image, and that can be turned into a new video stream that you can re-inject via WebRTC, for instance, to watch the results in real time. And the result was something like this, where the use case was, let's say, safety on the job, like you make sure that you are wearing a helmet in a dangerous area or something like this, basically. And having UDP notification as well basically helped us to feed that data via data channels, again, via WebRTC in real time. So it made it much easier for us to work with that. And basically, how do we actually feed Juturna in that sense? And one important point is that we really want to stress out is that even though I made that slide where Janus and Juturna are husband and wife, it's not an exclusive relationship, if you want. Basically, Juturna just needs RTP packets. So if they come from Janus, that's fine because that's how we use it. But really, whatever component can generate RTP, whatever you are using for RTP and can send video to that, it's really fine. But of course, if you can send it from Janus, that's even better. And the way that we do that is basically using a functionality that we call RTP forwarders, where in principle, the name says it all. So basically, with WebRTC streams, we can collect WebRTC streams in real time from different sources. But WebRTC is still RTP on steroids, I like to call it. And so basically, Janus does have access to the raw RTP streams, which means that those RTP streams can be forked and sent to other destinations dynamically for further processing. And for instance, we use it a lot for scalability for our own platform, for Janus, to feed, for instance, the transcription service and for a lot of other things. And the main problem was that originally this was only available in a couple of plugins in Janus, which are the Audio Bridge and the Video Room plugin, which implement conferencing at different levels for audio mixers and NSFU video. And again, that's what we use heavily in our own virtual event platform. So if you ever attended an ITF meeting using our own platform, basically everything is built on top of this very functionality. And basically what we wanted to do was make it available in the SIP plugin as well in Janus, so that even SIP calls handled via Janus could basically benefit from the same functionality in order to have streams forked externally to do something more with that. And basically, just to explain it in a more visual perspective, again, this is how Janus typically works. So in case you're not really familiar with it, basically, the SIP plugin in Janus implements a collection of SIP endpoints that can be created on behalf of WebRTC users, which means that if you have a SIP infrastructure that does know nothing about WebRTC, you put Janus in front of that, and it becomes a SIP infrastructure that can interact with the WebRTC world as well. WebRTC users never see SIP at all. They only see SIP endpoints in SIP URIs and stuff like this. And then they just interact using web-based events and stuff like that with Janus. And Janus is where SIP traffic is originated. So all invites are terminated there, that kind of stuff. The important part here is that Janus is acting as a media gateway also between WebRTC users and the SIP endpoint, which means that it has access to RTP traffic coming from both of them, which means that we can do something like that. So we can fork the media selectively. We can decide which of the streams we want to forward to an external component, how many copies of those streams we want, because we may have different backends interested in the same media. And this is basically all RTP forwarders are. And they open up to a lot of different use cases, interesting use cases. And in terms of how the functionality is implemented and exposed, it pretty much mirrors how it was available in the other plugins. But the important part here is that now SIP calls within Janus have access to the same functionality and additional stuff that you can do with media that other plugins had before. Like, for instance, of course, AI/ML processing becomes an obvious scenario because of the presentation that I'm making right now, but there's much more that you can do with that too, because you can implement now coaching scenarios, monitoring lawful intercepts, stuff like that. You could even broadcast a SIP call if that makes any sense. Like, for instance, a SIP call is actually a podcast interview between two people, and you want to broadcast that to a much wider audience via YouTube, for instance. That's something that you can now do using that functionality. You could do external recording without relying on SIP-rec if that's an issue, stuff like that. And this functionality specifically was sponsored by a couple of companies, Portadialer and another company that we work with. So we are really thankful for them for actually sponsoring the addition of this functionality. And in a nutshell, basically, this is how it could look like for a SIP call, where, for instance, you have a pipeline where you have two different audio RTP sources, where it could be, for instance, one for the caller, one for the callee. You can process them in parallel, possibly by sharing the Celero and transcriber node rather than having two different copies. This is just for visual simplicity. But in principle, the idea is that this is a potential scenario for instance, transcribing a SIP call in real time using Juturna and then having a diarized you unify the results from both transcriptions, and then you notify them together in a diarized way to an external component. Again, very simple example, but this is something that is now available thanks to this functionality in the Janus plugin. And this is it, basically. So in a nutshell, Juturna is a young project because basically I think we first released the first commit we did was probably a year ago or something like that. But in this year, it already saw a lot of evolvement. There were companies that were interested in from the very beginning, and we are working with them already. And so it has evolved a lot. The architecture has changed a lot also from when we first started because, for instance, it was not originally multi-source, multi-sync. It was really a one node in, one node out kind of thing, and now it's much more flexible as a result. And this was really possible thanks to that, again, I'm stressing the fast prototyping nature of Juturna, because basically we had a lot of ideas that we wanted to play with this year, and this was only possible thanks to the fact that we could write nodes very quickly in order to start experimenting with different models on the fly. And I'll actually make a dangerous demo about that later on, and I know nothing of Python, so you'll know how dangerous this is just because of that. And I mentioned how we used it extensively in production ourselves, specifically the transcription part, but there are also some of our customers that are already using it in production, specifically for some SIP use cases, and typically contact centers and stuff like that. But really what I wanted out of this presentation was really to introduce the project to you all, because what we really would like to do is to create a community out of this as we did with Janus. So of course, a project is only as successful as the people make it, basically. So if you are interested in this, if you have interesting use cases, if you have models that you want to start using quickly in a real-time fashion, Juturna may help you do that, basically. And the fact that you can write your own nodes in a very quick way should be, let's say, an interesting opportunity to dig into that. And especially considering how young the project really is, this could be the right moment to get in and help us also, let's say, change a bit parts of the architecture if you think it makes any sense. Especially considering that, again, Juturna is meant to be something that you can deploy wherever, even on a Raspberry Pi or whatever you want. So basically, one of the strong points is also the fact that you can really control basically the endpoints on your own. You can put it on premise. You can do pretty much whatever you want with the data and stuff like that. So that's it in a nutshell. And this is it from me. I'll check later if the guys are angry with me or are they happy with me. But if you have any questions, I'd be happy to take them. Thank you.
Okay, thank you. And questions about Juturna? We have here.
Thanks for it. So how it is easy to set up this, in containerized environment?
I mean, the setup is pretty straightforward. I mean, it was easy for me because I wanted to experiment with it for the dangerous demo, and so I really just followed the documentation as a dummy user of the platform that had not worked physically on that thing. And it is really very easy to set up because, for instance, you can just use pip to install Juturna out of the box, and you'll get the framework right away. And then creating pipelines is just a matter of launching a command. It creates the pipelines for you and stuff like that. And you can launch them. And I'll also show how you can create a pipeline and launch it very, very easily. Writing nodes is also very quick and fast because basically you have creators that can help you create a stub of the node that you need, and then you just need to fill in the different parts, so implement the different callbacks that need to implement it and stuff like that. So we spent a lot of time to try and make it as easy as possible to get in there and start tinkering with it and playing with it and possibly also break it as easy as possible.
Okay. Do you have any performance metrics available? Like what kind of load test you have tested with this?
Yeah, the performance metrics typically depends on the nodes that you actually use, of course, because those are the ones that do the heavy lifting and so on and so forth. And so, for instance, for the transcription part that we use in production at the ITF, we did publish a paper with some data that we collected at the time. So the platform has changed a bit, so the pipeline has changed a bit, so those results may change. But it seemed to perform. I mean, I don't have access now to the paper right away, but I can share it with you later on if you want. But it seemed to perform well enough. So, for instance, something that I didn't say is that all those nodes that communicate with each other, they exchange payloads, let's say on a contract-based sort of thing. And basically, the data is never copied in between those different transitions. So it's all done with a zero-copy idea in mind, which should help with making all those transitions also as, let's say, less impactful as possible with respect to performance. But again, the actual performance assessment really depends on the nodes that you involve and the different things that you do with them, basically. The idea is that Juturna itself shouldn't take that much at all in terms of resources because it's really meant to be a lightweight aggregator of different things.
Okay, I think it's time for dangerous demo. So Lorenzo will be here. Sorry, you still wanted a question? Okay, a quick one until James is getting set up.
So I was just wondering about the difference between the two different kind of remoting protocols you've got. You're basically running RTP and protocol buffers kind of in parallel. Why two?
No, yeah, the purpose of those two is different because basically in our case, RTP is acting as the way to get real-time media in a Juturna pipeline. And then within Juturna, how the media flows is a different matter, basically. And then RTP is just one example of how you can source media in Juturna because we have source nodes that can work out of a file, that can get media via HTTP or whatever. It could be media over QUIC in the future or stuff like that. So that's just how you get media in Juturna itself. And then the warp node plays a different role because in that case it is a processor node that sits, let's say, within a pipeline. So it has data coming in and it needs to shoot something out to the next node. And in that case, that node may need to refer to a remote model, like for instance, you want to implement an interface to OpenAI, for instance. And so, of course, you don't have a local OpenAI instance. You need to communicate with it remotely. But you have a local OpenAI node that basically abstracts all that so that the node before and the node after see a local node they are interacting with. But this node is actually interacting with a remote component.
Okay, thank you, Lorenzo. James, you ready?
Yeah, I think I'm ready.